And here, the third video in our series on rather unusual trig equations. Here we go. Use algebra to solve cosine theta plus root 3 times cosine pi on 2. Take theta equals 0 with theta equals 0, with theta belonging to the interval 0 to pi. This is an interesting question. Now, first of all, we need to recall our formula for cos pi on 2 take theta. Now, if you expand this as cos A take B, it is going to work, but it's going to take you an unusual amount of time and open you up to mistakes. So, as always with these questions, the best way to solve it is with a trig unit circle. Isn't that always the case? So there we go, make it a little bit larger. Now, if we remind ourselves, now annoyingly I can't seem to move that so it's right in the centre, so I'll probably draw it by hand, be better. Okay, so there we go. No, we're not going to do it like that, we're going to draw it by hand. There we go. And there we go. Okay, so this is just to remind us of these symmetry properties. So if this is angle theta, which we put there, then pi on 2 take theta, of course, is a quarter turn anti-clockwise followed by a move back by theta clockwise. Okay, now if we use this diagram to remind us, cosine value of pi to take theta is there, and we remember from our proofs much earlier on in the year using congruency, that is equal to sine theta. Okay, so there is our formula. Once we have that, most of the work is done. So what we want to solve now is cos theta plus root 3 times sine theta equals 0. Okay, now hopefully at this stage you may have figured out that we're going to have to deal with a tan equation. Now there are two clues to this. The first is that we've got a mixture of cos theta and sine theta. The other clue is that we've got root 3 in there, which is a tan exact value. Okay, so what we should do, of course, is we should divide through by cos theta. So divide by cos theta. So if we do that, what do we get? We get 1, cosine theta over cosine theta is 1, plus root 3 times sine theta over cos theta equals 0. And of course we know that that can be rewritten as root 3 times tan theta, because sine theta over cos theta is tan theta, is equal to negative 1. Okay, which of course translates through to tan theta equals negative 1 over root 3, and that can be rationalised to negative root 3 on 3. And there we have a very easy to solve trig equation. Okay, so let's solve this equation using the usual technique. Step 1, find the base angle. The base angle, which has a tan value of root 3 on 3, is pi on 6. This is in your formula sheet if you don't know it by heart. Next, let's draw a little quadrant diagram. So, tan is negative in quadrant 2 and quadrant 4. Remember, tan alternates. Positive, negative, doesn't it? So be careful with that one, that's a bit more unusual. Okay, and then finally, we don't need to adjust the domain because we're just trying to solve tan theta equals pi on 3. As a result, we can immediately write our solutions. So, our first solution in the domain 0 to pi is going to be in quadrant number 2, and it's going to be pi take pi on 6, which is going to be 5 pi on 6. And the second solution is going to be in quadrant 4, it's going to be 2 pi take pi on 6, which is 11 pi on 6. And there are my two solutions. So really not a very difficult problem as long as you remember a couple of key things. First of all, this formula here is essential to remember to be able to solve this problem easily. And to be able to find this formula, all you need to do is sketch a unit circle. So practice your unit circle symmetry properties. Okay, the next thing that we need to be able to recognise is that we have a cos and a sin mixed situation, which often, although not always of course, if we look at video 2, the one just before this one, with the sine 4x, we had a mixture of sin and cos, and it wasn't a tan equation, but it often is, and in this case it most definitely is. Okay, this is a nice little problem, not too challenging.